Okay, so I hope you can hear us. We're live now with Tomas and Dmitry, who are going to talk to us about Helidon. Let me see, do I have people in this session? Okay, so I hope you can, let me see, once again. Hello, hello. Let me quickly share the screen before the top of the hour, just kind of to remind people that we need them to be involved. And we would love if you can join, but I want to show the slides so you can kind of see how to join and be aware that you can join us and follow us on Twitter, on Facebook, on LinkedIn, and now that we have our YouTube channel, please follow the YouTube channel as well. We would love to have the traction there. And on that same YouTube channel, we will have all of our sessions uploaded as well. So that's one way to be in touch with us. The other way is to really get involved with Jakarta EE and then become Eclipse Foundation member, join Jakarta EE working group, and then start working on the specifications. All you need to do is the ECA, and if you were available to attend the Will's presentation earlier today, you know that he shared everything on his screen, and we will be more than happy to share that presentation with you as well. So yes, please get involved and help us out on the journey with Jakarta EE. So now I will actually stop sharing my screen and invite Dmitry to share his so he can start with the presentation for today.
Yes. Okay, thanks, Tanya. So do you folks see my screen? I hope so.
Yeah, we see your screen.
So we're at the top of the hour. Let's get started. So welcome to Fly Like a Rocket with Helidon session. The main goal of this short presentation is to give you some details about upcoming Helidon 2.0 release. It's a major release containing many new features. The agenda is that I give you a short introduction using slides, and the rest of the presentation will be a demo driven by Tomas. Safe harbor required by Oracle. You should not make critical business decisions based on my presentation. A little bit about myself. My name is Dmitry Kornilov. I'm Helidon project lead. Here are some contact details. Feel free to contact me if you have any feedback. So this is how I looked before self-isolation, and this is how I look after that. If you don't know what Helidon is, it's not an application server like WebLogic, OpenLiberty, PR, etc. It's a Java libraries for developing microservices like Spring Boot, Quarkus, or Micronaut. Actually, there are two Helidons, Helidon SE and Helidon MP, two different frameworks. You use one of them in your microservice, not both. We created two Helidons because we don't believe that it's a good idea to mix two development experiences. Helidon SE is our reactive non-blocking framework. It's designed with performance in mind. It's similar to what Netflix is using for web services. It's similar to what Apple is using for web services. It's super fast and very small. It provides modern development experience with lambdas, Fluent API builders, and so on, with no magic. No magic means we don't use annotations where it's no dependency injection, but instead you have a full control of your application. MP is, I would say, a modern version of enterprise Java. It's cloud friendly. It supports MicroProfile and some Jakarta EE components. It provides familiar Java EE or Spring Boot-like development experience with annotations and dependency injection mixed with magic. So Helidon 2.0, this is what this presentation is about. It's not released yet. It's a preview. The release is planned in second quarter this year, but they already released 3 milestones, and the third milestone was released yesterday. You can use it to try new features and give us some feedback. Important to mention that Helidon 2 increases the minimum Java version requirements. Now it's Java 11. In Helidon 1, it was Java 8. In this version, Java 8 support is dropped. Helidon is not only Oracle product in cloud native Java family. There are currently 4 products. The Logic is our Jakarta EE application solver. Coherence is our in-memory cache solution. By the way, the open source version of Coherence is going to be released soon too. Helidon, this is what I'm talking about now, and Verrazano, Kubernetes-based hybrid application management solution. Talking about Kubernetes, there were 2 talks with Kubernetes before mine. Sebastian and Adam use Kubernetes in their demos. So it's an industry trend now, and many customers are considering migrating their solutions to public or private clouds and embracing Kubernetes as the development platform. Oracle Cloud Native Java solutions are based on Kubernetes too. So it allows customers to migrate to microservices architecture using their own pace and deploy it on premise or in Oracle or any other public clouds. Oracle provides enterprise support for cloud native products, and Helidon is not an exception. Helidon support is included in support contracts for products listed on this slide. It's variations of the Logic and Coherence. So now let's finally talk about Helidon itself and new features. And I'll start with Helidon SE. So on this slide, I put all Helidon SE 2.0 features. Newly added features are marked green. We already had a non-blocking web server, configuration, security, and observability components, but we were missing some functionality to make out feature complete. We are closing this gap by introducing DB Client, which is non-blocking database access API, Web Client, which is non-blocking HTTP API to call other services, Reactive Streams, Reactive Messaging, WebSocket API, which was requested by many users, and CORS support. Now we have a full set of non-blocking APIs, which you may require to make fast non-blocking service. We're also introducing a new JLink-based profile and Helidon command line interface, and I'll talk about these features later. Now let's jump to Helidon MP. That's a similar slide. We support MicroProfile 3.2 fully, and these components are marked light blue. We support some Jakarta components. These boxes are highlighted dark blue. We continue supporting MicroProfile specification and adding implementations for reactive streams and reactive messaging. We're also adding WebSocket, Jakarta WebSocket, and CORS support and MP, but the main feature in Helidon MP is GraalVM native image support. Tomas will demonstrate it in his demo. But I talk about the build profiles a little bit more. So we support now 3 for comparison. In Helidon 1, we supported 2 in SE and only 1 in MP. So the first one is executable jar file. It's been fully supported from day one, and it's a hollow jar. It means that it contains only application business logic. All third-party dependencies are collected in a separate directory. It's done for better Docker layering support, and this is what Adam Bean was explained in his talk. I'm not going to repeat it. Using this approach, you can build your Docker images really fast and upload, download stuff faster. The second profile is JLink. It's new in Helidon 2.0. JLink tool, it was introduced in Java 9. It's used to build Java runtime environment, which contains only functionality requested by your application. It makes your overall image size smaller. It also optimizes your application startup time. And what's very important, it doesn't introduce any restrictions to your application. So you can code using everything what Java provides. And the last profile is GraalVM native image. We support it in MP since version 2.0. And it allows you to build a native executable native image, GraalVM native image, based on your application, with advantages of almost immediate startup time and lowest possible memory consumption. As a drawback, it introduces some restrictions to your application related to usage of runtime Java features such as reflection, proxies, and so on. It becomes important when you use some third-party libraries which are not GraalVM optimized. Here is a slide about better understanding how these images are related. So I created 3 images based on our Helidon MP Quick Start application. And sorry, it jumped too early. So here is the Docker image size comparison. So you see that jar profile image is the biggest. It's 200 and something megabytes. It's because it contains the full Java runtime environment. JLink image is smaller. It's just under 200 megs. It's optimized, and GraalVM native image is the smallest one. And startup time, you see the same picture. So the startup time for the jar profile is the highest. It's almost 1.6 seconds. It was done on a fast computer, by the way. JLink profile is 1 second something, and for GraalVM native image is almost immediate. But on the other hand, what is 1.6 second startup time? Right, this is almost nothing comparing to the time of pod provisioning in Kubernetes, which may be like 30 seconds or something like that. Okay, now jump into the second feature, Helidon CLI. It's a command line utility created to make developers' life easier and more fun. It simplifies project creation. We have several SE and MP templates to choose from. It also has a development pod which tracks your source code, recompiles it, and reruns your application if it detects some changes. We call it live restarting. It's very convenient day, and it was highly requested by the community. It's still in active development. We are planning to add more very interesting features soon. I don't want to spend much time here. Tomas will demonstrate it in his demo too. DB Client. Helidon DB Client is non-blocking database access API for Helidon SE. When you are developing a non-blocking service, accessing a database was always a challenge. It's mainly because there are not too many non-blocking database drivers, and adding blocking database access functionality to your non-blocking service doesn't make any sense. So with DB Client, it's not a challenge anymore. It adds non-blocking database access APIs and allows you to use existing blocking database drivers in a non-blocking way. Sounds a little bit complicated. Again, Tomas will demonstrate it if he has time in his demo. So DB Client API supports relational and NoSQL databases. It supports all Helidon observability features, such as metrics, health checks, tracing. It doesn't introduce any new database access language. Database native direct is always used. it uses convention over configuration in a way that all database statements you use in your application are externalized in configuration files, not in the code, which adds limited portability. So you can switch databases by changing only configuration without recompiling your application. React Client, another new API in Helidon 2.0. It's a non-blocking HTTP client. It's designed in Helidon SE reactive style, supports all HTTP operations, provides full integration with observability features, and it follows redirects. It also can be extended by extra functionality. Tomas will demonstrate it in his demo again. Reactive streams and messaging. In the previous milestone release in M2, we introduced reactive streams operators and reactive messaging support in both SE and MP. In MP, we're extending our MicroProfile specs list by adding implementations of the corresponding MicroProfile specs. In SE, it's done by adding new APIs in Helidon SE style. It has actually huge sense for SE because reactive streams processing is must-have functionality for modern non-blocking frameworks. By the way, reactive streams implementation is contributed to us by David Kornilov, who is a famous guy in reactive Java world. He is the father of Project Reactor 3. We have a goal of delivering one of the fastest reactive streams operators implementations. And here is a comparison of our implementation with SmallRye. SmallRye is a reference implementation of MicroProfile streams operators. You can see that we are about twice faster, which is perfect result for us. And the last feature I'm going to highlight is CORS. What is CORS? Browsers by default are using same origin policy. So browser can access resources only from the same origin that provided the app. It means that you have your application on the server, you access it via your browser, you can't access any other resource other than located on your server, which sometimes is a little bit of a problem. And to solve this problem, exists cross-origin resource sharing. This is the stuff which controls access by the app from one origin to resources from another. It uses HTTP headers for that. And in Helidon, we support it fully in SE and MP, and it's automatically supported by Helidon features like health check, metrics, and OpenAPI. So for better understanding, so this is a slide explaining how it works. So suppose hospitality.com hosts an application that retrieves friendly messages from other apps. And we have a Helidon quick start application running on myserver.com, which provides some greeting, right? So in your browser loads the welcome app from hospitality.com, and hospitality.com becomes CORS origin. This application requests something from myserver.com. It does get on greet results. So host becomes myserver.com, and browser CORS implementation adds host and origin headers to your request. So server receives the request, passes it to Helidon application, and Helidon application checks is this resource and this method allowed for resource sharing. If so, then entity is returned. If not, then 4 or 3 is returned. So it's as simple as that. How it's implemented? In SE, you create a CORS support, basically build it using a builder, and you add cross-origin support to the builder. The first one allows put requests and allowed origins are hospitality.com and other.com. And cross-origin support.create basically allows everything else to other origins. After that, then this CORS support is created. You just register it the same day as in your routing. Important that it should be added before registering the grid service, which it works for. In MP, it's even more easy. It's just annotation cross region. There you provide all the required information. Okay, 19 minutes. I supposedly have enough time for the demo. Thank you very much. And I'm passing the control to Tomas.
So before you do that, maybe just a quick question. Is there a list of JDBC drivers that are native image friendly?
Oh, that's actually a good question. So there are some drivers which are native image friendly. So we tested it on H2, right? And there are some other drivers provided by Red Hat, which are native image friendly. And what I can say that Oracle works on making Oracle DB driver native image friendly. But unfortunately, I don't think that it comes with Helidon 2.0 release. It may come later on this year. I don't know exactly the date.
Okay. Thanks for the question, Alice, and of course, Dmitry, for answer. And let's see, Thomas, if you can share your screen. Okay, it's good. You can
Very
see
good. All right, so I will start by using our Helidon command line interface to show how it works. So let's just show that I downloaded it. It's a single file download. I will talk about it a bit later when I have a few moments during our build. So first thing that I want to do, I want to create a new Helidon application. So what I'm doing here, I'm creating a version 2 milestone 3 application with SE flavor. Of course, you can use MP flavor as well. Now this will create an application. If I look here, you can see that it has the usual Helidon application prepared with a Docker file, YAML file for Kubernetes and the sources. Now, the next thing I can do, I can build my project, but because I already have Helidon running, I just want to change the port. So I will do a quick fix here. I will change the port to something that's not blocked. Now I will do a Helidon build, and I will give it native mode. This is an example of ahead-of-time compilation using Oracle GraalVM. We support it, as Dmitry said, both in SC and in MP. I'm showing it on SC because it's faster and it doesn't block us that much. Now I can talk about the Helidon tool itself. It's actually built using native image as well. So it's really quick to start, and it's written fully in Java. The good thing in Helidon is that all the things that you see here, building of the application, building of the native image, and building of a Docker file, Docker image, are done using the usual tools that you would expect. So you can use pure Maven, you can use the GraalVM native image to compile it if you provide all the appropriate switches, and you can build Docker using the Docker command. So as you can see, my native image is built for Helidon SE. Now I can just start it. You can see it booted really, really fast, running on port 8089. Now, I wanted to show a few things here that are interesting when it comes to size comparison. We talked about it a lot, and the price of resources was discussed many times. So we can see that the full size of the native image is 23 megabytes. And this is an application that contains everything that you need. You don't need JVM, you don't need anything else, that's it. We can compare it to the actual size of the libraries that are used by Helidon. So that would be the libs directory for SE. You can see that the whole sum of all dependencies of Helidon SE is 5 megabytes when you use the basic configuration. And of course, we can have a look on the size of the application itself, which is 12 kilobytes. It's the whole jar. Dmitry talked about it. That's why I wanted to show here. I will show some parts of the CLI later. So let's finish this screen and let's go to my Helidon application. So before this show, I have created, using my Helidon init command, an SE application and an MP application. For Helidon SE, I'm using what we call a dev mode. You just do Helidon dev, it will start your application, and whenever you do a change, it will make sure that you get the latest version in your in here. So you don't need to restart it manually. It's all done behind the scenes for you. I also have an MP application, and here I will just show what I did before we started, because this takes a bit more time. So I have built the native image for our MP application. I will scroll down to the important stuff. So here you can see that the build time is 2 minutes. There is no free lunch. You pay for stuff. So if you want to have ahead of time compilation, you obviously need to build that compiled file, and that takes time. And the bigger your application is, the more dependencies you have, the longer it would take. Of course, you also need a bit of memory to be able to compile that. Now, the application can be started. So I will just start my MP application, and now I can go and show what's actually in this application. The startup time here, it's printed here, it's 55 milliseconds. There are a few things that must happen when you start an application in native image, such as loading of your configuration, because you don't want to be stuck with the configuration you had at the time you compiled your application. Now, this is the source code of my Helidon MP. And what's really important here, this one class. This is our JakartaOne resource. And this is the only thing that we need to have a working JakartaOne or REST application in Helidon MP. It uses the usual annotations of JakartaOne. You can also use annotations from CDI, such as at inject, to create a new instance of this resource, injecting our greeting provider. And of course, that uses MicroProfile, because we are an implementation of MicroProfile. So here we are injecting config property. When you build this application, it uses a main class that comes from Helidon, and that just boots the CDI, which takes care of everything. So obviously, we need to have our beans.xml file, and then we have the MicroProfile config properties to set up Helidon. So here, what I'm doing, I'm preparing the server port, the listen address, and then I'm configuring the service of the tracing, because I want to also show tracing later on. So I think that there was a lot of stuff said about MicroProfile. So the last thing I will do with that is I will show how we handle the Docker Docker image. And of course, I need to be in the MP. Okay, and I don't have my history here, so come on. This is what always happens when you switch around too much. Now, here we are. So I will build a Docker image from my MP application. Let's see if it worked. You can see it's quite fast because of the layering that we talked about. I have changed nothing in my application, so it didn't need to recompile, and it just created a Docker image. The good thing, I think, for users of Docker is that it's actually using the Docker command. So we don't have a custom Maven plugin. We try to use the tools that are built for the task. And for building Docker images, we think the correct tool is Docker. Now, let's go back and start talking about the new stuff in Helidon SE, because that was the most complicated part. So I will switch to Helidon SE. And what I prepared here is an application that uses a database, and it calls another service using our Reactive client. So I will start from configuration. So first thing, again, we have the tracing configuration to be able to see the two services that are part of our communication chain. I have to change the port so we don't have a conflict. So our front end is running on port 8060. And now comes the configuration of the database. And this is what Dmitry talked about. We try to keep the database configuration solely in your configuration file. So if you decide to switch from H2 database, which is an example here, to Oracle database, for example, and you need to change your selects, you can just do it in the configuration file, and the application will work the same way. So here you can see that we configure our connection. Helidon actually supports encryption of keys in the configuration files, both in Helidon SE and in Helidon MP. So if you want to do that, you can. Of course, you can also use Kubernetes secrets and load those files as an additional configuration source. Now here you can see the statements. We have one that is kind of system statement that is used by health checks if you have them enabled. And then I have just a single select here that is using, that's called get greeting, that will select just something from the table in our database. Now that's it. Let's have a look how that looks in the source code. So I will close our MP resources, and let's have a look at our Greek service that is responsible for handling it. So I will start with creating our web client and DB client. So if you have ever played around with Helidon, you may have seen that we like builder patterns and fluent API. So we try to allow you to build everything in a flow. So here we create a builder. We give it the configuration of the database from our configuration file. I configure an interceptor, which is a database counter. So this will add more metrics into our database. And I just build the client. And I will immediately show how I build the web client. So here I'm just using a base URI hard-coded. The web client similarly has a possibility to configure this using our configuration. I just didn't want to do it. I wanted to show one using programming and one using the configuration. We add the support for JSON processing here. And again, I'm registering a counter and then building my client. So this is the first step. We prepare it when we prepare the instance, and these are reusable. So later on, we use them in a route. So let's have a look how the routing works. So for those who haven't used Helidon SE, we have the concept of routing where you configure rules on a specific route. So for example, this service is registered on /greet, and it registers its own subpaths for various HTTP methods and paths. So here we can see that if you call get request on the root of this service, we have some default message handler. If you call get request with a name parameter in the path, it will call the get message handler. That's the one I will talk about. And then we have a put support on /greeting that will update the message. So the one that I played around with is the get message handler, which normally, if you create our quick start, will just print hello and the name that you have sent. What I changed here is that I have decided to call the database first and see if we have something stored in the database for that user. So here you can see that I try to execute a database statement, and here we have the named get statement, which uses the get greeting name. So this is the mapping to the configuration file. And I gave it the parameter. It's the name that I have received. So if I go back to the configuration, we can see that I'm using the usual JDBC approach of a question mark instead of a parameter. We also support named parameters, so you could actually do something like this, but then you need to provide a named map of parameters when you execute your statement. So this named get returns a completion stage because it's a non-blocking environment. By the way, it's important to understand that for JDBC, which is blocking API, we obviously need to do something about it. So this is handled by using an executor service. So even though it's non-blocking, there is still a set of threads that will block on the JDBC calls, but they will not be blocking the server, and they will not be blocking other routes that are executed in this server. So when I execute it, I get an optional with the result, because a get is basically a statement that returns either nothing or a single record. And if it's not found, I just return a 4 or 4. If it's found, I will invoke the other service, And of course, we need to handle exceptions. So if, for example, if it returns more than one record, something has to happen. So I just send the exception over the wire, which either sends the stack trace over the network or just a 500 error, depending on configuration of web server. So here what I'm doing, I'm just reading the column number 2. You can also read columns by name from the statement. I generally don't like ordered parameters, but it's the simplest approach is just to use the ordering number. And I read it as a string. And now my call MP method is the one that is invoking the web client and calling our Helidon MP service. And here for the web client, I'm just saying that I want to invoke a GET request. So that's the HTTP verb. I'm giving the path, which is the name that I have retrieved from the database. And I execute the request. And again, this returns a completion stage because the request is happening asynchronously with a non-blocking approach. When it comes back, I just copy the content from the outbound request. So I copy the status, then I copy the content, and that's it. And again, exception handling. So this is a full reactive flow of querying a database and invoking a web service with the result of the database. Now, you can also see one important thing here. Reactive programming is, in general, a lot of scaffolding and not that much business logic if you compare it to synchronous programming. So you get a huge amount of performance out of it, parallelism, but you also pay for it with the complexity of writing such code. And I'm really looking forward to Project Loom finally hitting the JVM, because then we should be able to have synchronous invocations without the price of blocking threads. All right, so the whole thing is set up. I have my Helidon SE running in my Helidon dev mode. I have MP running from native image, so we should be able to actually invoke it. So let's do our curl command. I have a single record in the database, which is for Jack. It should return Sparrow. And so it does. So now you can believe me that we have queried the database and called the remote service. I can prove it. We have tracing. There was a lot of stuff said about all the observability features, and tracing is one of the most useful ones. So what I can do now, I will just search for all the traces that are in my system. And you can see that there was an SE call. So there was an HTTP request coming to our Helidon SE on /grid/jack, which is what I have done using curl command. And now I can show that whenever you use a Helidon feature, we always think about metrics and about tracing. So when there is a database, you have the possibility to hook it into the tracing chain, and you can see it here. So we have seen that there was a get operation in the database. There is the select that was executed, of course, without parameters. We have the database type, and if I show all our records, it also says that it returned a single result. Now the next step is our HTTP client. So here, this was the GET request called to a remote server. And here you can see that we have switched context. We are now in our MP server that is processing this query and handling it. Now, as usual, the first request is slightly longer than the subsequent ones. So I will just show how it looks when you have a warmed up application. So it's 12 milliseconds look much better for an outbound call. So that's the tracing part. And the next part is metrics. So let's have a look on how metrics went. So I will just do a curl with for the metrics. And we can see that we have two metrics registered. There is the counter for localhost that's coming from the web client. And we have the DB counter for get greeting, where I have decided to have for each statement that we would have a different counter. So here we can see that we called get on localhost with a response 200. 3 times, and we called get greeting 3 times as well. So this was all my commands. I could of course try non-existing one, so we can see we got the 404 back. And now if I look on the managed to type correctly, we can see that the numbers are now different because, of course, the get greeting returned no results, so we didn't even call the remote service. So this was how it binds into our metrics. So you can see that both metrics and tracing is working. One thing I didn't do, I didn't actually add health check support for the database. We have it. I missed that one. So if I do our command, but this time I will request health. And you may have seen that all these commands are repeated over and over again during today, and that's because obviously this is all coming from MicroProfile specification. So even though we are using Helidon SE, and you can see that we have a few checks that are registered by hand. I have actually, these are like built-in health checks in Helidon that you can use if you want to. So we have deadlock, disk space, and memory health check. So even though in Helidon SE, we provide a reactive implementation of libraries to build your microservices, we have adopted the MicroProfile APIs that are not CDI specific, and we are using them as well. So basically each Helidon feature that you can see here is somehow connected with the MicroProfile API. There is one exception, which is config, because configuration, we have designed our configuration before MicroProfile came into being. But for metrics, the format that you see, you can also you can get the JSON format of MicroProfile or the text format of Prometheus. So I can show that here. If I go to, so it's 8060, and I will do metrics. Just do application. You can see this is the usual Prometheus format that you get by default. Or you can request a JSON format, which is MicroProfile. The same thing is for health checks. We have adopted the health check format of MicroProfile even in Helidon SE. So it doesn't matter whether you choose to use Helidon MP or Helidon SE, the observability features are the same. So you can use the same tools to monitor your application, to troubleshoot your applications. Another thing for tracing, actually tracing is also part of MicroProfile specification, although it's basically using the open tracing specification for all the APIs except for one annotation. And if you use Helidon SE or MP, they both propagate automatically all the required headers for tracing. So if you have incoming headers from Zipkin and you use Zipkin yourself, and then you call another service that uses Zipkin, you will automatically get all of this in your Zipkin tracer. The same comes for Jaeger as well, obviously. All right. I think that I have gone through all the things I wanted to show you. As you have seen, the native image worked the same way as if I launched the application using Java. So the MicroProfile in native works. We have tried to limit the amount of things you have to adhere to be able to use the native image, but obviously, and that was already said as well, native image is tricky because you need to be sure that everything that you do will work in a native environment. And ahead of time compilation using Graal, for example, does all static initialization at build time. So even though you can use almost everything from Java except for method handles and a few other things, you need to be aware that whatever you do in a static initializer will be initialized at build time, and then when you run your application, it's just there and you can do nothing about it. So that's the reason why we differentiate as does Quarkus, obviously, between a build time and a runtime, and you need to be very much aware of what you do in which of these areas. So if you build your own CDI extension, for example, you need to make sure that you initialize things at the right time. And with that, I have gone through the demos. So if there are any questions, I think we can go to that. Or if there is anything else you want to see from Helidon.
Yeah, please. Now it's the opportunity for questions. And Dmitry, thank you for answering Mary's question. Mary, good to see that you're here. So
okay, I can see it now. So let me answer. Sorry about that. I missed the question. So is Helidon underlying reactive stream support Reactor or reactive messaging? So I think Dmitry answered. Yeah, we have our own implementation that is neither. So that's how we decided to do it in our case. For the JDBC drivers that were mentioned before, as far as I know, there is no driver that works without modifications. We are actually using in our example the Quarkus H2 driver. And thanks for guys from Quarkus to actually doing that work, because it's demanding, and with every new version you need to go back to it. The only driver that I managed to use, I think, was the Mongo Reactive driver with DB Client that worked without additional changes in native image. Okay. Thank you very much for your attention then, and enjoy the rest of this conference.
yeah, so we are going to start. Well, first of all, thank you, Dmitry and Tomas. This was great. Thanks for participating and supporting and being part of the JakartaOne Livestream. For others, we are going to start next session at the top of the hour, so I can see you there. But I also want to take the opportunity and just share my screen briefly. And if you're interested, give you a little bit more details on how we can, how you can further help us out. So, and what other news are out there? So I told you to get involved. I already mentioned earlier, and I think Will was mentioning earlier that we're preparing annual JakartaOne live stream in September. So keep your eyes and ears open for that. For Portuguese-speaking people, please be aware that August 29th, there is going to be another JakartaOne live stream. If you are interested in organizing JakartaOne live stream in your local language, do not hesitate to get in touch with me. I'll be more than happy to help you out. And then we're organizing Eclipse Con 2020 as a virtual event. And we already know the dates. So please register for the event and mark your calendar for October 19 to 22nd. You already know how many compatible implementations we have out there. So you can also visit the on Jakarta EE website, the compatible implementations, and read about them. Let me see, what else can I tell you? I am hoping that you're all familiar with Adopt a Spec program for JUGs. So if you are a member of any JUG that is particularly interested in one of the specifications, please let us know. We would love to get in touch and officially put your logo on the Jakarta EE website. Subscribe to our YouTube channel. Projects and community mailing lists, and I will stop with highlights or focus from the on the Jakarta EE 9 release. We already talked about this earlier, or Will rather talked about this earlier in his talk, but wanted to share again and invite you to get involved. We still need a lot of help with the change of the Jakarta or Javax namespace rather to Jakarta. There is still tons of work to be done, and we are looking for more participation from the community. Let me see, are there any questions? No questions for me. I didn't necessarily... one thing that I could show you is actually... So one more thing that we just put out there for people who want to get started with Jakarta EE. This is being developed, but for the time being, you can also see some of the examples and starting point projects. So if you're, again, interested, please get involved there and let us know if you have any feedback, and help us further develop the true starter for Jakarta EE. And I guess that is it. Any more questions, comments? If not, everyone, thank you so much for attending, and we'll see you in the next session. Thanks, Tomas. Thanks, Dmitry, again. Bye for now.
Bye.